Some prerequisites for you to understand the information I'm presenting are that you have a basic understanding of BizTalk Server 2004 orchestration, that you've also done some basic orchestration correlation, although I'll show you how to do that. This is the ability to be able to send messages out of orchestration and then receive messages later and correlate those with an active orchestration. Of course, you'll need to understand how to configure orchestration ports, messages, variables, and other typical orchestration artifacts. Finally, your send and receive ports need to be configured and your adapters and your pipelines when you actually deploy the solution. And of course, you'll need to be able to understand how to build, bind, enlist, start, and enable the various BizTalk artifacts when you deploy your solution to understand how to do this. So with those prerequisites in place, let's talk about Convoys in a little more detail. Convoy is basically a pattern, a design pattern in orchestration that allows you to do advanced message processing where you control, or you may not be in control of, the order of the messages being received by your organization or by BizTalk. Messages are treated then in a single-threaded fashion, meaning if a given message is received and a following message needs to be part of that same business process, all that execution will occur in one instance of an orchestration running on a single thread of the BizTalk process. There's two broad categories of convoys. You can think of those as parallel or serial convoys. The more technical term that you see in the product documentation is concurrent correlated receives, which are parallel convoys, or sequential correlated receives, which are serial convoys. An example here that you see on the screen is basically having a clearinghouse example where you might have various brokers or parties sending information into your system, and those various parties then are passing that information through to a clearinghouse. This clearinghouse is then needing to receive information that all correlate on a transaction ID, in this case 1023, and then spit that information out to a file or out to a remote system with that same transaction. But it's important that all this information is received on the same thread and that clearinghouse processing does not continue until all three parties' information have been received by the BizTalk process. So let's talk about the first type, parallel correlated receives or concurrent correlated receives. Allow you to receive this information from various partners in any order and not continue processing until all the appropriate documents from all your partners or all your systems are picked up by BizTalk. At that point, you then are able to continue processing and doing whatever actions are required on these various messages that you receive. Messages are going to therefore arrive in a non-deterministic order in this design scenario, this design pattern. An example of this might be that you need to receive a couple different purchase orders that require taking information from partners. Maybe you are a manufacturer that needs to fulfill an order that has many different parts that you're actually receiving from various vendors. You have to wait for all those vendors to confirm that they can give you those parts, and once they've confirmed that those parts are available to you, that you then can acknowledge back to the customer, hey customer, I actually have all these parts in stock and I'm able to fulfill your order. So realize that in those cases, various partners you communicate with might be returning information back to you in varying orders, and you may not know which partner is going to respond first, and you don't want to continue processing that order until obviously all the partners have verified that their piece of the product shipment is able to be fulfilled. So some specifics about this design pattern: when you're building it in BizTalk, you'll use the orchestration shape, orchestration schedule with a parallel action shape to implement this. These parallel action shapes allow you to do multiple back-end processing simultaneously, although in this case you're actually using the parallel action shape to allow you to receive multiple documents simultaneously in a non-deterministic order. For each received shape in the orchestration, you need to make sure that all those received shapes are activatable, because this is actually what is kicking off your orchestration. You're actually launching an instance of the orchestration based on receiving one of several messages. Because you don't know which of those messages is the first one that's going to be received, you go ahead and set activation true for all the messages. By doing that, you're able to actually understand that no matter what message I receive first from which partner or which back-end system, I'll go ahead and activate my instance on that first message. All following messages that I receive in my parallel action will not activate, obviously. My schedule is now active. I will simply correlate on that. So it's very important that we also correlate And when you correlate a message, that means that you pick a specific entity of that message, a specific field like a purchase order number or a transaction code or something that's unique about all those messages you're receiving, so that you know that they all relate to a common thread of execution that you want to correlate on. In this case, it might be a purchase order number that each of the various vendors is responding back to you with, so that you know this specific response from each vendor relates back to one specific order from one specific customer. And once all those individual PO numbers from all those vendors enter the system, you can continue processing that purchase order. The important thing to note is that the messages can be received by different ports. You could have obviously one vendor pushing data to you through your website via HTTP post. Another might be dropping files to your FTP site that you're watching for, and a third vendor might be simply using a web service and posting to a SOAP address. So you're able to receive messages into one orchestration through many different receive port mechanisms and then continue processing from there, so it's very flexible. Now, the other broad category of convoys are serial convoys. Serial convoys allow you to receive information in a deterministic order where you exactly know the order in which documents should arrive. Now, you may not know how many documents are showing up, but you do know that you are first receiving possibly a purchase order request, and then you're receiving maybe an invoice fulfillment. Maybe your process is tracking the overall status of a purchase order being fulfilled. So you first want to make sure the purchase order is received. You want to make sure that the invoice is sent back to the customer, and then maybe you want to verify from the customer that they've submitted payment. So you know the order in which documents or messages are going to arrive to BizTalk. You just don't necessarily know how many documents might arrive. In a serial convoy, it's possible to actually do looping, so that perhaps your job is simply to continue to receive updates. Maybe you're a stock quote system, and you want to receive stock quotes on a continual basis in a certain order or in a certain format. And as you continue to receive those stock updates for a specific company, say Microsoft MSFT is their symbol, their stock symbol, you continue to receive those updates in a serial fashion. You're just receiving those via a while loop, and at some point you actually decide to kick a message off, maybe when the stock price jumps a certain percentage amount. So when that happens, you can then take that information and actually make a while loop and decide at some point to break out of that while loop and send maybe an update to all the folks that have subscribed to your service to get stock quote updates. Some keys to designing a serial convoy are that you want to correlate the individual messages as they are received. Just like with a parallel convoy, you have to create a correlation set. Something like the stock quote or a transaction number or PO number would be used as that unique ID. It could also be metadata on the message that you correlate on, maybe a file name. Maybe you're continuing to receive files with the same name and you want to correlate on that common file name over a period of time. Your receives are going to continue to come into the system, but you don't fully define the point at which you want to continue processing until you've received that last message. And so the way that you do that is you just keep receiving messages in a non-activation state. You first receive that initial message that activates the schedule, and then the remaining messages that come in are non-activatable. And they will continue to basically correlate on that same correlation token. Two categories then of sequential convoys, if we look at sequential convoys specifically, are either having homogeneous or common messages that are coming into your system. Maybe a stock quote follows a specific schema, and you're just continuing to pick up the same stock quote over time that might vary throughout the day. And so you're receiving the same message, or basically it's a homogeneous system with the same message coming back time after time. Another term for that is uniform sequential convoy. The other example might be the other scenario I mentioned, where you have a purchase order and then follow that with a invoice that's sent back, and then finally purchase approval or payment by the customer. Those different messages, we're going to have different schema types, different XSD schemas, and therefore they're going to be heterogeneous in nature. You're actually going to have different types of messages arriving into BizTalk, and so it's going to be non-uniform processing of messages. You know the order in which they will come into your system, you just know that each one will look a little different. So an example of a serial convoy might be where you have one activatable receive that initially kicks off your orchestration, and then you initialize your correlation set at that point to be based on the orchestration key field, maybe a transaction code, PO number, or stock quote, and then all the following receives that are in possibly a while loop are going to be correlated but are non-activatable. So here's those two broad categories that are shown here on the diagram. First is our uniform or homogeneous sequential convoy, where we receive an initial message here, and then we continue to loop to receive additional messages of the same type. The non-uniform or heterogeneous convoy might receive multiple messages, but they may have specific types for each of the message. In this case, maybe a healthcare provider first provides us some information about a patient that was seen, and then there's additional information being processed about that patient, whether or not the bill's going to be covered, and then for parts of the bill that are not covered, how that payment's going to be taken care of. So those individual messages may be of different types, and therefore we'll receive those messages as non-uniform messages or unique messages, where the first receive actually receives in a specific activatable mechanism and the other two receive in a non-activatable state. But they all still have to correlate. So in the end, correlation is key to all these convoys. You do have to correlate on a common ID. That way, if a totally different message enters the system that's unrelated to the current processing, you want a separate instance of orchestration to kick off and start processing that second mechanism. In the example of healthcare, you might have one patient that's seen a doctor, and so there's convoy processing for that patient's information, and then another patient is seen by a different doctor. You want to make sure, obviously, that that's executing in its own thread or its own instance of orchestration and correlating on that patient's number or patient record number. So I'll go in here and actually do some demonstrations of these correlation examples and these concurrent correlated receives, otherwise known as convoys. Let's start with doing a parallel convoy. So in Visual Studio, I've already built up some artifacts for us to take advantage of. I have a purchase order schema that I've created. It's a very simple schema that contains simple fields, a PO number, and a total. So this is going to represent a purchase order that's being submitted to us. Now, as part of this process of parallel receiving of information, we also want to receive an invoice before we continue processing. So the invoice itself contains a number, a total price, and an actual status. Once we receive our PO, we then want to track that PO against its correlated invoice. And once we have those two pieces of data in hand, we can continue processing. Now, in this scenario, we don't know in what order those two pieces of data are going to enter our system. So this is an example of a parallel convoy. We're going to receive two different types of messages, an invoice and a PO, but we don't know in what order those are going to enter our system. So the way that we build this is we create an orchestration in our BizTalk project. And for that orchestration, we're going to receive our POs through this PO port. And this is a very simple PO port. It simply has a couple pieces of data that allow us to define the port name. It's a port type, PO port type. It's going to be receiving messages on a specific port, and I've gone ahead and specified that port at design time. That way it builds my ports for me when I deploy the solution. I'm going to be picking up my purchase orders from this in folder, and they're going to have the name POstar.xml. And it's just simply going to watch a file folder for that PO. Now I have another port here that's picking up invoices. This invoice port specifically is receiving invoices, again, from a port out there, the same in folder, but this time it's looking for PO invoices with the file name invoice something.xml. Critical then for the PO and the invoice to be correlated with one another, we have to make sure there's some unique identifier that both the invoice and the purchase order contain to allow us to tie those two together to a common thread of execution in orchestration. So it's important when we look at our PO schema and our invoice schema that we identify that field that will contain the same record. In this case, it's going to be the number field for our invoice and the PO number field for our PO schema. So what we need to do then is create a correlation set and a correlation type that identify that number as our unique token. And of course, for that to be correlated, we have to make sure we promote that property. And you can see that we've already done so. We see our little medallion here next to the field for PO number and for number. If we look at our actual properties and see which properties have been promoted, we do see that there is a common property called purchase order number. It's a promoted property that uniquely maps to the number field for our invoice schema and maps to the PO number field for our PO schema. So even though the field names are different, they're going to contain a common correlation token, 1, 2, 3, 4, or a GUID or something that's unique, so that when we receive both types of documents, that one field has to be the same for both documents so that we know how to correlate and continue processing. Then what we're going to do in our orchestration is after we receive those two documents, we can then continue processing, and that simply involves mapping the documents. In this example, I've got a simple map where we take in the purchase order and the invoice, and here we're showing the power of the transform shape in BizTalk 2004 to actually allow you to transform multiple messages that are being received into a common output message. So we're actually taking our PO and our invoice, we're concatenating together the numbers to create a new number. We're taking the total prices, adding those together to create a new total price, and then we're taking the status field, and in our concatenation functoid, we're just adding one more piece of configuration data in the input that actually adds the word final invoice in front of the status. That way we know the initial invoice plus the PO creates a final invoice for us. So the next step then is to do that actual parallel processing, the parallel or concurrent correlated receives. What that involves is simply adding to our shape the parallel action shape. So we go here to the parallel action shape, and in parallel, we're going to be able to either pick up the PO or pick up the invoice. We don't know which is going to come in first, so we simply need to insert a receive shape in both sides. In this case, this is going to receive our PO. And on this branch of our parallel action, we're going to have another receive shape, and that's specifically going to receive our invoice. So we can actually go ahead and pick which type of message we're receiving, and I've already created the messages here in my orchestration. So if I go and look at my orchestration variables, I can see I've got specific messages here, orchestration messages, and I've created an invoice in message and a PO message to represent at runtime within the orchestration instances of those messages as they flow through my BizTalk system. So PO message maps to my PO schema, and invoice in message maps to my invoice schema. And while I'm here, my invoice out message is actually going to be the same type of invoice schema. It'll still use the same invoice schema, but it'll have some new data after I've done my mapping process. So then I just need to let my receive port know that I'm receiving a message of type PO message, and let my receive invoice port know I'm going to receive a message and assign it to the invoice in message. So now I've got basically a variable or a message variable sitting around that has basically an entire copy of that PO and that invoice, so that if I need to do any kind of custom manipulation or logic on that data, I can do that now that I've got an instance of that message and a variable referencing it. The next thing I mentioned is that both of these receive shapes have to have activation set to true, and that's a property of the receive shape. So I'm going to set that to true for both receive shapes. Normally in a typical orchestration, you have one receive shape at the top that has activation true, and that kicks off your process. Normally you don't ever activate in more than one place in a schedule. This is the one design pattern where you can activate multiple receive shapes simultaneously, and that's only possible because orchestration realizes that we've got a parallel action occurring at the top of our orchestration, and in this case it's the very first thing that's occurring in our orchestration. So we do have to activate the orchestration, create an instance of it, and we do that by creating this activate equals true property. So that if we receive the PO first, we're going to activate the schedule, and then when we receive our following invoice, the invoice is going to correlate to that PO on the same number field, the PO number field, and then it's going to continue processing. So even though we've set activate to true for both of these fields, do know that it only activates on whichever message is received first, and then the other message simply correlates. So how do we actually do correlation? We've got to create a correlation type. So I'm going to define a new correlation type, and I'm going to base it on that promoted property, and this is why I had to promote my property, is so that it shows up in my view as purchase order number. So that's my promoted property, purchase order number. This correlation type, I'm going to go ahead and give it a friendly name, PO num correlation type. And then I have to create a correlation set based on that type. Correlation type is really just a definition of the correlation set that I'm then going to actually create here. So now defining a PO num correlation set, and that correlation set will be based on my PO num correlation type that I created. So now I have an actual correlation set I can use to do my correlation in my orchestration. So here on my receive shape, I need to initialize my correlation set by picking it, and I do the same for both the receive PO and the receive invoice shapes. Now that I've actually picked up receive PO and receive invoice, and I've correlated those with the common token PO num correlation set, it now knows how to tie those two messages together. Now I simply am going to bind up to my ports, and these are basic ports for receiving POs and invoices from a file location. I then am going to construct a new message, my invoice out message, and I'm doing that here in a transform shape. So my construct message here is going to construct a new invoice out message, and it's going to transform that message using the input of PO message and invoice in message, and the result is going to be an invoice out message, and it's simply going to use that existing map, PO and invoice to final invoice. Of course, my BizTalk project has to be signed properly, so I'm just going to show you that it does have a strong name file assigned to it, public-private key pair that it's going to use to sign the document as it's deployed to the GAC, and I'm just going to deploy locally on my machine. So I'm going to right-click and deploy my solution. I'm going to go over to BizTalk Explorer, refresh my view here, verify that my assembly's been deployed. Looks like there was an issue. Let me return to my orchestration here and view my output window to see what might have occurred. Looks like deployment had an issue. It appears that it built successfully. Let me just verify that I don't have any other orchestrations configured at this point. Everything appears to be in good shape. I'm just going to verify that my project properties are correct. That's my computer name. And my assembly strong name file does exist. Let me try just deploying again. Okay. I'm going to view my task window to see if there's any additional details that I might be able to glean from the task list. Looks like it says here the host is not specified for my orchestration, so it's using the default orchestration. Receive handlers have not been specified for the receive location. Let me verify that my actual receive locations don't exist, because that can cause some problems. Well, it looks like actually the deployment did work. There was just a slight delay in the refresh on the screen. So my Convoy has been deployed successfully here. What I need to do now is actually bind and enlist my orchestration. It actually has already built up the appropriate bindings for me since I did early binding for those ports. So I can simply enlist my orchestration, which is going to create a subscription in the message box so that it will be able to pick up purchase orders and invoices that are received on those ports. And I'll actually physically start the processing, and by starting the processing, it's actually going to kick off and enlist and start any dependent receive locations, as well as enable any receive locations, send ports, groups, and also start my BizTalk host if necessary. Once my orchestration goes from kind of a gray color to kind of a full color, I'll know that my binding is complete. Looks like everything is now started. I'll just verify my send ports are started, and then my receive ports are enabled. Both receive ports are enabled. So now to actually test this process, I'm going to take a file, in this case my PO. The unique token that's going to correlate the PO with the invoice here is 1234, and total amount for this PO is $19.99. I'm going to copy that into my in folder. In a little bit, that's going to be picked up by BizTalk, depending on the processing that my server is doing right now. And once that document has been picked up, I'm then going to drop an invoice. And this invoice, although it has a different structure, has that one unique token that ties it to the PO, which is that number field, 1234. It's important that those two things be the same so the correlation occurs. Okay, so I go back to my in folder and I see that the document's picked up, so now I'm going to pick up my invoice, drop it in my in folder. So now a correlating invoice and a PO have now been picked up. I go to my output folder, and based on my current day and time, I see that I've got a new invoice out here that has concatenated the two numbers together as my map had done. It's added the totals of the invoice and the PO together, and it's thrown that final invoice status in front of the original status of the invoice. So actually correlated and processed. Now to show you that this works in either order, remember that I dropped PO first followed by invoice. Now I'm going to drop invoice and follow that with purchase order. It's going to still correlate on both, and the output will still result here. Now, what if we had two different documents flowing through simultaneously? Will it correlate successfully on both? We're going to take an invoice of 1234 and a PO, in this case, that has a purchase order number of 5678, and we're going to see if that actually correlates. So we copy these two. Let me clear out my outbox so we can see if anything shows up there. I drop to my in folder. Both get picked up. When I go to my out folder, though, I'm not going to see anything, because basically an invoice with one purchase order number was picked up, a PO with another number was picked up, but the two don't correlate. So what happened? They're basically both sitting out there waiting for their pair to be received. The invoice is for 1234 is waiting for its PO to show up, and the PO for 5678 is waiting for its invoice of related type. To show you this in another way, let me show you health and activity tracking that'll just show you the current status of any messages and any service instances running in our system. What we're going to see are two different instances waiting for a pair. What we can see here is we've got parallel convoy going on, two separate instances. Both have been dehydrated, and they're basically waiting for their pair to show up. So I come out here and I take my 5678 invoice and my 1234 PO, which are the pairs for what I just dropped. Put those in my in folder. I go back to HAT, I run my query. I see that those two instances of orchestration are now gone because both received their correlating partner, and the result will show up in our out folder. So we've got one for 5678 and another for 1234. So that's Convoy processing.